Welcome everyone to our second Masterclass Monday. We are very proud to have you here. Some of you maybe again. So because this is our second episode of our Masterclass Monday webinar series. Embedded Wizard is the GUI solution by Terra Systems. My name is Kristen. I'm responsible for marketing and communications here at Terra Systems. And together with my colleague Manuel, who is Embedded Wizard's product manager, you will explore the Embedded Wizard Studio today. Afterwards, concepts like the Composer, Inspector, or Debugger will be easy to use tools for you while you develop your UI with Embedded Wizard. One more thing I want to mention regarding the organization of this webinar, feel free to post us your questions right away in the question tool. We'll be coming back to these after Manuel's presentation. And there's only one last thing I want to mention at this point in time. We will be recording this webinar, so it will be available for you later on our website. So now I hand over to Manuel. The stage is yours. You can start.
Christine, thank you very much for your pleasant introduction. Yeah, good morning, good afternoon, good evening to everyone who's now watching this second episode. So I'm very proud that you're here. And last time we asked you to vote what topic we should discover and explore in more detail with the second episode now, which you have now selected with a very big number of votes have selected the Embedded Wizard Studio, so the IDE. What I'd like to present with you in the next couple of minutes is to give you further on a short overview, and then we will really dive very deep into each of the components of the IDE. That means the composer, its members, we explain, or I explain the bricks, which is the visual representative of different items. I'll explain how to use the gallery that you find on the left side of the IDE. I'll show you the usage of the inspector and different meanings. We dive into the log window, which becomes essential, especially when you are tracing and debugging your GUI project. And finally, the so-called debugger gets used, and I'll explain how the debugger is helpful for your system. Last but not least, I'll also give you a short overview about the shortcuts, or my favorite shortcuts that are very essential when using the studio, which accelerates the overall development quite a lot. So let's jump into Embedded Wizard Studio. For that, I'm just now making that small and starting the Embedded Wizard Studio free. And as last time, just creating a new project where I say this is now the master class series 2, creating a new project. So what you see when you create a new project for the first time. In fact, that was already mentioned in the last week's episode, is different views. First of all, we have the so-called menu bar here on top of the window, the menu bar and the toolbar. We can do different things like starting the prototyper, like building this current profile, so generating the sources and further things. Next to that, we have on the right side the so-called inspector, which gives you all visible or all included items depending on dedicated Z ordering. Then we have the so-called composer with its different bricks, which shows you the current user interface, or especially going now to the application, which would show you how this current application looks like. We have the editor on the bottom right side. We have the so-called log window, and finally we have the status bar here on the bottom of the total view. The gallery is then used to drag and drop the elements, and this is now something how I'd like to explain now in more detail. So when going back to the project, then you see how the Embedded Wizard Studio project is overall structured. We have different elements, the so-called bricks. For example, the so-called unit core or the unit resources, all of those belong to the so-called Mosaic Framework. The Mosaic Framework is the base that is used for your GUI project in order to do very simple drawings like rectangles or text views, but also for more sophisticated elements like a 2D perspective transformation, so with warp views, warp images, warp groups, or to maintain also the different kind of effects that we have. For example, color effect and integer effect, etc. These are provided with every installation out of the box, with every installation of the Embedded Wizard Studio, and are also deployed in full source code for your further usage. And so you can also see how different kind of elements inside the Mosaic framework are implemented. Next to the framework, we also see here the so-called unit application. So by the way, a unit is something like a container, like a group, where you can structure the project according to logical elements, like the main application. Now, usually inside bigger projects, you would have different other units, like a unit which contains all different image resources or fonts, so different assets which are used to define the proper view of the user interface, or other units like the integration to your middleware, to your business logic, which is something like device integration. These are then structured in a logical way. Furthermore, you also see a different other brick, which is the so-called profile brick. And that profile brick is a definition of how Embedded Wizard should then generate and react on proper platform settings, like screen resolution, the platform package to be used with different color formats, etc. Finally, we actually see now the language brick. Per default, every new project comes with a default language, and if you want to extend your UI project with different multiple languages to be supported, so that you can switch from German to English or vice versa during runtime inside an entire project, then this would be maintained with that dedicated language brick. Furthermore, something which is also essential, you see all different kind of annotations and notes inside this view, and those are simply for documentation. So don't get worried. Those different kind of annotations and views are used only for information purposes. They are not used when it comes to the generation generation of the source code for the embedded system. So that means those do not have an influence on the memory footprint, maybe the RAM footprint or the flash footprint. So you can really document, you can put the dedicated information inside the view where it is actually needed, and you do not need to maintain different other documents or system overviews about the GUI project. You can document inside the project where it is actually needed. So let's go now into an application. So that means an application is the entry point inside a GUI project. The workflow, the typical workflow that customers are using is now to drag and drop elements from the gallery into the composer. That means, for example, inside a class, visual class, you can drag and drop elements, so standard elements like this rectangle, like an image, like a wallpaper, text, etc. Or when going now to a unit, so that means the container, you can also add different other classes. So just see the different. When I now try to drag and drop the element of a view, it's also working, but this now comes in a different flavor. You see, it's not made visible because it now depends to a unit, and it is also represented by a different visible view, which is now in that case a so-called auto object. That means it's just simple an object initiated once or every time it is accessed, and this is something comparable to the so-called singleton pattern. So for example, if you want to have a global data entry, a global element, a global object that can be accessed from all other objects being initiated inside the system, this is something where you can now directly go into that. So this is for the auto objects. When there's just a ready-to-use class and this class needs to be initiated, this is auto objects. However, you can also add a different, only a class for that. So as you see, or I think you're already aware of that Embedded Wizard follows a very a proper object-oriented programming approach. So that means you can define classes. Those classes have different behaviors, have different properties, and if you want to use them, you need to initiate them, and hence you then have a dedicated class. So back to the workflow. Within the gallery, you can drag and drop the elements from the left side to the units or also to the project. Just drag and drop a new unit now into the project. However, you cannot drag and drop, for example, an element which would only belong to the project to the unit. Yeah, for example, you cannot drag and drop the element unit into another unit. So you cannot define different containers within a container. Or for example, drag and drop a language element into a unit, or drag and drop a language element into dedicated class implementation. No, a language element can only be drag and dropped into the project view. So this is something that have to be kept in mind depending on what kind of implementation you would like to achieve, depending on what kind of element you would like to add into your GUI project. So just removing that as of now. So drag and drop different elements now from the gallery into dedicated views. If you want now to navigate between different elements, it's very easy. For example, a unit can just be opened by double clicking on that, and it's opened. Just going back, when I'm now closing everything. So double clicking on the unit opens the container. Double clicking now into a class definition, like this core root application, opens now the implementation of the class. Having now a dedicated rectangle, for example, and when you would now double click on that initiated object on that rectangle, for example, this then opens the implementation of the current selected object. In that case, it is the views object. So going now back to the application. Next to visible elements, you can also drag and drop things which are essential to implement logic. For example, a method, for example, a slot method, for example, to add a property, for example, to add a variable. However, a constant cannot be added, but a constant can be added to a dedicated unit. Okay, so going back to the application. Something which is also essential when you see inside the composer is how things are made visible. Embedded Wizard follows a very strict visual approach. That means things that can be made visible are rendered instantly, whereas things which belongs to development or to GUI development and cannot be made visible are represented by those called bricks. Think about, as mentioned, a method, a slot, a property, how to draw them, how to make them visible. In fact, we decided to follow this approach to make this visible as these bricks. With these bricks, in fact, you can now also go ahead and structure them according to your needs. Just think about you only have not only have one property and one variable, just think about you have multiple properties that you're drag and dropping. As of now, it's not very well structured, but what you could do, just to give you an idea, is to rearrange them according to your needs. And I think it's just something which is something that customers are used to do when they are working on the first time. Then you would simply have a different other view on the different kind of properties. So this is the on set, on the on get, and with that you would then easily have a different definition and an easier view of different other elements. And with the possibility to have this kind of bricks available in a visual manner, as you see, you can also easily then define how these elements should be structured. In that way, I have now just grouped them a little bit. I have ordered them a little bit better, so that you or customers or myself would then see, okay, this is the groups of properties. The same I could do now for the slots, for the methods, for different variables, etc. And with that, customers do then not need to change different views, from an editor point of view where somewhere is a method defined, back to the visual representative where the rendering process is, or the visual result is made visible. This is not necessary, so you stay all the time in one view at the end. So I showed you how to drag and drop the elements. I showed you how to navigate. Of course, you can also navigate here with the mouse. You can, by clicking on the right mouse button, select where to jump now into a different unit, for example. For example, when you have now opened multiple other units, so just doing this multiple times, you can also rearrange different views so that you have, okay, my application should always be on the right side. And when you're now inside the application, you can then say with right click on the mouse, let's go to my unit core, and then it jumps, or go to the project. Or finally, you can also say close other composers as well. So this is also there. However, something which is essential when going now to the composer, you see also different kind of how bricks are represented. So what I did with those elements, I just added them in a new way from the gallery now to the composer by drag and dropping. However, just remember, I said embedded wizard is structured to be or to follow the object-oriented approach. We also have different kind of methods that might be overwritten according to your individual implementation. So for example, there is the so-called handle event method, which is a method that takes care about receiving events. So maybe a touch event, maybe a key event, etc. And if you have some individual requirement to manipulate that event before going to further instances, then you would need to override that handle event method accordingly. To do that, you would simply say, okay, let's copy, and on the right side, do a derived paste. So this is one option. And then you see how this handle event method is now looking a little bit more different. Of course, the size can be adapted, but the main essential point that I'd like to point out is that the original method, so the new method that we previously dragged and dropped from the gallery into the composer, is written in black text, whereas the overwritten method is or represented, the text is represented in a gray text color. And you also see that an overwritten text element gets bold inside the inspector. So this is something that needs to be kept in mind when doing an overriding of different members. So maybe now a method, you could also do an overriding of properties or variables or whatsoever. Then those gets represented in a different way, just like the bounce property. The bounce property just defines the screen resolution now of this class, of this core application class, core root application class, and per default it is now overwritten in order to match the initial setting of 640 by 480 in size. So it is overwritten per default, hence it is represented in gray text, and here it is represented in a bold text manner. So this is for the composer. When having a more detailed on different kind of bricks, every brick is structured or has 4 parameters that should be kept in mind when looking at a brick. For example, the method, what we have here, or the overwritten method, comes with a dedicated icon. So every different kind of element is represented with a different icon. It comes with a proper name. In that case, it is the handle event method, and it is also indicating how this or what type of this method is. In that case, we have a method. Just think about the property. Those all have different names: property, property 1, property 2, and they come as integer 32. So now changing, for example, this property to a so-called, let's take a string property, for example, then you see that the type of this property is now also changing inside this representation of different strings. So we have the icon, which depends on the type. We have the proper name of that brick. We have the type of the brick, and we also tried now to make things more visible also when looking at that. So for example, all methods and slots are shaped in this kind of view, in this parallelogram, whereas this data structures like variables and properties, in that case, those have these 6-pointed rectangles, for example. So, and with that, customers get easily used to see how different kind of bricks are represented by its name, by its icon, by its shape, and this helps a lot. Going now back to the project, something that I just mentioned before, we have now here inside the project few different other bricks which cannot be used inside a unit or inside a class, for example. We have the profile that, as said, defines how sources are generated, how the prototyper is used by defining different properties like the screen size, like defining which application class, depending on the profile, is used, where to output the generated sources, and finally which platform package should be used. In that case, it is just the Win32 platform package. We have the language, which defines which language should be used. We have units, and something which is also used inside the view is a so-called style. That style is, for example, used if you want to implement different kind of themes, different kind of variants for different resolutions, for different brands, for example. But how to use those styles is not topic for today. It will be a topic for another masterclass Monday session. So we have these different projects right now. Perhaps now is the time to jump more, or to give you more an overview about different kind of the menus or the toolbars. Something that I already mentioned is how to navigate between the different UI projects. Double-clicking on the element opens the next view like that with the class, etc., etc. So you just then jump into the very low implementation, like the draw method here of this views rectangle. Going back with a right click gives you the possibility to navigate then back again into the application. Whereas, for example, now the handle event that we have derived now from the original handle event would now open inside the editor the new implementation. However, how now to navigate not between containers and classes, etc. The question would now be how to navigate through the different relations of derived elements, for example. So having here now this handle element, then you would see, okay, you cannot navigate inside this structure. This handle event can, however, be navigated by using these icons here. And what does it say? Navigate to the ancestor. So by double clicking that, then you see, okay, this handle event has been overwritten from the core view. Double click on that, which opens now the implementation, the original implementation of this handle event. And so with that, you can also then navigate to the superclass. Where does it now belong to of my core root? Being there, or going back now to the application and gives me to the very first entry would also be the case, which is then the same as the ancestor, and inside that it's the core view class. So this is what can be done inside the navigation. Next to that, you can start the prototyper. You already know that. So by pressing here the play button with the circle around it starts the application class. That is always the entry point when starting the application. However, you could also now implement a new class, for example. Of course, this cannot be prototype because it's not visible, and this is also mentioned here inside the log view, that you cannot a class because it's not derived from a viewable core group class. However, usually you would structure your project by defining different kind of components, like adding in that one a new component which comes or which is derived from core group, and this can be prototyped. Playing now here the play button, which would now only prototype this element. To make this a little bit more visible, just adding a very simple text and say, this is my component, and defining a simple bigger font, so extra large one, changing the view and changing the color, so just some black. So by pressing now the simple play button, so without the circle, opens the simulator, the prototyper, for the currently open view. In that case, it's application component, and you see that that is being prototyped, the application component. So with that, you can focus on dedicated implementations for dedicated classes, and you do not need to navigate or to start the simulator, the prototyper, from the beginning and navigate then to a dedicated sub view in order to find out that you have misspelled component, which should be written in small letters, for example, and not with a big capital in the beginning. Of course, anywhere where you are, so like now in the implementation of a dedicated application component, you could now press the play button again, which would then start always the core root. So that means the main entry of dedicated main UI, which is the application class implemented. Something which is also essential when it comes to the navigation is to navigate between the Z ordering. The Z ordering is indicated by the so-called order number, which you see inside the inspector. So selecting, for example, now this rectangle shows you that this one is ordered at position 166. So when I'm move the rectangle to those images and that wallpaper image, then you see that the rectangle is drawn first and the other two items are drawn now above the rectangle view. However, if you want to change the Z ordering, the simplest one is just to do the restacking up and restacking down elements. For example, when you're pressing that button here, so restacking up opens or changes now the Z ordering, which was before 166 to 168. And with that, you can then do a simple restacking of different elements. Of course, you can restack them backmost, which would then at the bottom, but you could also restack them topmost, which is then the highest Z ordering. So the higher the Z ordering number is, the more it comes to the visual place. However, something which is also important to know is that also non-visual elements, so like the method or the overwritten handle event method, that those also have a dedicated Z ordering. And this is now essential when initialization, for example, comes into place. Just think about, you would have here the method, the new method with a Z ordering of 169, and that would now refer to the property 1, 2, or 3, which would have a higher Z ordering. With having that, that means if you would now access properties in the initialization phase, to access those properties inside that method, whereas the properties have not been initiated due to the higher Z ordering, that would give you not the expected result. So please take care about also the Z ordering of non-visual elements, so like methods and properties, etc., because they also have an influence when they're going to be initiated. If you want to build the project, then just opening that menu bar there, you can also create or let Embedded Wizard Studio generate the sources by using this element there. However, what also comes into place if you have multiple profiles. As of now, we only have one profile, so Tara Win32 RGB 888. However, if you would have a second project, let's assume, I'll make just a copy and paste that. So for example, if you want to generate for the web as well, then you would have two profiles, the default one, and now let's pick here the WebGL platform package as a second one. If you want to generate the sources for both profiles at the same time, then you would just say build this in batch mode, which could then be enabled by checking that accordingly. And by now hitting the build button would then let Embedded Wizard generate the sources for both different profiles instantly. So this is for the building. However, something which is also essential, which I always use quite often inside the application, just think about different changes of the bounds. As you probably might know, you could also change the bounds directly by drag and dropping those elements there, or just hitting now Control Z to make those revert, go to another view. Which is just the simple component there. So changing here, for example, the bounds. So the size of that component would also be indicated here inside that new view, which has now 470 by 340. However, you could also change that immediately to, let's say, 100 by 100 pixel, and by pressing OK, I have now added, I have committed now these changes to the bounds property. However, you see that it's still the same with the same size, with the same width and the same height. Now I need to say Embedded Wizard, I have now changed the visual representative outside, because by adding new parameters to this property, and by hitting here now this reload class button, or by pressing F7, you would say to Embedded Wizard, please take your properties now into account and reload the class. This helps sometimes when you do not see the effect initially. Okay. Let's talk now more about the gallery itself. You already saw that I drag and drop elements now to different views. So to the classes, you can then add, like I said before, properties, methods, etc. Or to the project, you could add new units, for example. However, how do I now find my own implementations that I edit? So now going back to my application, I have added a dedicated class, and let's say this is my special class. So just hitting F2 on my keyboard, which then allows me to rename that, and I have my new component, so which is the same as selecting here by the right mouse click, rename member, to say, okay, this is my view, or let's say my screen, something like that. And then you are now inside your application, and you want now to initiate and have a representative of the own implemented my screen implementation, which was this small one. So let's just make this a little bit bigger, because otherwise you would not see it. So which is my simple component. Now it's not a component. We have to set it is my screen. So going now to application, how do I now find my my screen implementation of the class, and how to initiate that? For that, you do need to change the view inside the gallery. First, it was templates. So these are the predefined templates that are available, may belong to the Cora environment, may belong to the Mosaic, which is the views, may belong to ready-to-use widgets or different effects, etc., event handlers. But this is something I'll explain another seminar, another masterclass Monday. So for example, the Mosaic Framework, I would explain this one. However, how do I now find my own implementation, which is the application my screen? Therefore, you need to change the view of the gallery from the templates view back to the browser view. And then you see all classes, you see all constants, you see all resources, you see all enumerations, sets, and all auto objects. So the question is, how do I see now my own view? when having this implemented, then you would first of all have the chance to simply search that. In our case, you would then say, let's find my screen. Okay, going, of course, collapsing that. This would then filter all classes in that way that we have this my screen application, my screen implementation of the component. So drag and drop will then just instantiate, sorry, the class, and this gives the representation of and the rendering of my previously defined component my screen. Of course, you can instantiate that multiple times. So we're drag and dropping those again and again. And with that, you have the possibility to drag and drop the elements that you have previously defined and hook that into the into your application and build dedicated components. So this is the gallery. So the gallery for the template, it includes the core language types, it includes predefined templates, it includes the ready-to-use widgets, and you simply just drag and drop those into the different composer views, whereas the browser view, this comes with all project members, so classes, the constants, enumeration, resources, and of course, as you see also with the hierarchy, so my screen is derived from core group, is derived from core rect view, derived from core view, the very basic one, and can be also drag and dropped instantly into the system. So let's now have a focus on the right side, which is the so-called inspector. The inspector is used to inspect and to modify all the members with their related attributes or properties. So by selecting, for example, now this use rectangle there, you have then the possibility to manipulate and change different properties of that elements and attributes. The attribute for this rectangle here will be, for example, the description, whether it is generated, and which class it is. You could also change now from a fuse rectangle to a fuse line. Hitting reload gives you an error, so that's not the case because the bounds does not work on that one. And then you see also that the inspector shows also errors inside the inspector. So for example, I have changed now a rectangle to a line, hence the property bound does not work anymore for that rectangle because a line doesn't have bounds. It has a 0.1 and a 0.2, which defines where this line belongs to, as you see here with these elements. So what to do now when I have this error in that way, so that is not made visible. So for that case, you have, or the inspector indicates that with the red text, and what you could then simply do, say, okay, let's restore to the default value, which would be the Control R on your keyboard. By that, it says, okay, the bounds doesn't belong to the fused line. It's then removed, and then hitting this reload class button there gives me my rectangle, or in that case, it's not a rectangle, it's a line anymore, now back. So, however, you do not see the line right now. Why? Because we have not defined the points. So let's make here, for example, the attribute 100, 100, which gives me now the line in that way, and I can drag and drop this according to my needs. So with the inspector, you can change different properties. So like the point, you can change different attributes, like to which class it does belong, and gives you the possibility to manipulate those selected elements directly where they are. So this is the inspector. As said before, you have or the views inside that inspector gives you also an indication about the Z ordering. It also gives you which type of element it is or is available in the current opened class, for example, and what is the name. By showing that in different kind of text styles, so like a big black and bold is a new element, whereas when it is gray or like this handle event in bold gray, then it is inherited and overwritten, whereas if it is in light gray, that indicates that is not overwritten and just used as it is in the previous defined class, for example. What we already used now is the log window. The log window gives you dedicated information how the current system is structured. So for example, when every time you open the prototyper, it gives you the proper information. Every time you generate this profile, it also says, okay, now generating code. If something is not working as expected, like here in this handle event, because it's missing, you need to do something, then it is also reported. So in that case, you need to give a proper return value like that one. And this should now disappear. And this gives you the information what's going on. However, as you saw before, just commenting that out, when you would now generate again, it tells you where is an error and how to identify now exactly where this error happens is very simple. You simply do a double click on that arrow, and this gives you the cursor now to the proper position where this error occurs. So being back, for example, I'm now in this slot method, double clicking that into the editor and double click now back again to this handle event. Error report now opens inside the editor automatically the proper point where this error occurs. So fixing that right now is very easy. However, something which is also nice that you can do is to do printing information. And I have read in a debugging manual of a semiconductor manufacturer that sometimes a very well-placed printf could be the best debugging tool. Honestly speaking, I must admit that sometimes it's very easy to just do a proper printing. However, printf is not available inside embedded wizard, but there's another command which is the so-called trace command. With that, you can say, okay, trace handle event is called, something like that. And by now starting the prototyper and hitting now on my keyboard the enter key, which would now see that these traces are popping up. So the traces are then not populated into the main window there. These are populated into a different view, which is the debug window. And then you see that my trace command that I have added here inside the editor is pushed now to this debug window as well. By double clicking on that would also now open the dedicated element inside the editor and gives you the proper point where this trace happens. So with that possibility, you have also very nice functionality available that it gives you the possibility to print and debug things. Of course, you could also do a search, but this is something I'd like to explain later when it comes to the hotkeys that I'm using. So we have the log window, which gives you some basic information, which gives you the information about the traces. And finally, we also have the editor. The editor is used to implement your desired behavior of your components with embedded with its own programming language, Cora. It gives you the possibility to traces. Something which is also essential when it comes to debugging is by pressing now the F9 key on my keyboard, which opens which adds a breakpoint now to this view. And this says that there's now a breakpoint. So pressing now the play button, hitting again enter on my keyboard, now invokes this handle event method and my breakpoint gets hit. And with that, you can now identify and see what are the current available variables lurking around in the system. You could also see what is my current call stack and where you can then navigate easily. With different step over or step into or step out functionalities or step through, you can then do a proper single step debugging. So for example, let's step into that, would then go into my core stack to different other views that you have. And this gives you the possibility to really do a proper debugging of your current implementation. And also keep in mind that you do not need to start the core application, you could also start your individual component that you have. So where is the editor used? In fact, what I already opened there is just now closing the debugger, not needed anymore. So the editor is used with when editing methods and slot methods, for example. A difference between methods and slot method is as following. A slot method is signaled in an asynchronous way, but different. Sender, for example, a button, when you just hit that button, would then emit a signal to associated slot methods, which could then invoked to see, okay, now I'm invoked, so I need now to handle this input of the user touch, for example, whereas a proper method, when I just open that method, has the possibility to get proper variables and return back proper return values compared to a slot. The slot, when just opening that again, you see you do not have any given arguments, and there's no return value which should be returned back. So question is, for a method, how to change now the arguments and how to change the return value. So that's very easy. Just double click now on this line here, which opens then the proper definition of the method. And then you see, okay, there's integer 32 method. By double clicking on that int32 defines now the return value. For example, you would like to return a string given by not a integer 32, by getting a float value, so or argument. Okay. Of course, you can also remove that. So just selecting that and pressing the delete key on my keyboard removes my method. So then I have a void method. By hitting the insert button on my keyboard, gives me a new argument. So default, it says it's a string, new argument. Let's take that one. Of course, by heading again the insert key on my keyboard adds another argument, etc. So you can add more and more arguments to a dedicated method. And with that, you can now simply say, okay, let's return string plus a new argument plus a new argument 1, for example. So this is the way how you define the methods of inside Embedded Wizard with the editor. So next to the methods and slots, you also have with the properties the possibility to change the onset and onGet methods. The or a property itself is the same like a variable, like we have here, but with onset and onGet methods. The setter and getter methods are then used when every time you're writing to a property, then the set property method gets invoked, whereas every time you're reading from that property, the onGet property method is called adequately. So double clicking, for example, on the onSet property opens the implementation of the onSet property. And with that, you can then add your custom code, or every time you're reading from a property would also then allow you to define your custom code when this property is read, for example. So just two more things I'd like to mention, or also functionalities of the Embedded Wizard before we come to the shortcuts section. In fact, the question is, or Embedded Wizard, is a source code generating framework and follows that approach. How to identify my things when they get generated. So in fact, we have different units, and with Embedded Wizard, every time I'm generating now this profile, this will generate one C file for each unit. So just going back now to my project, so my new project that I created, my new profile, and then you see that for every unit a dedicated C file is generated. So opening that, for example, with an editor gives you an overview how this is structured. And now the question is, how do I find my way back, for example, from the generated C code to my embedded wizard project? In fact, what you see now here is the so-called application handle event method. What we have is the first thing is the unit, which is in that case application. The second element which is indicated is here again application, but this belongs not to the class. And finally, we have the name of the method, which is handle event. So going back now to the embedded wizard project, says me unit application, the class application, and there I have the handle event method with the dedicated implementation. The previously added new method, which just returns a new string, is also identified as well. And now coming back to the Z ordering, the type of Z ordering is also important, or the order of the number of the Z ordering is important when also the source code is generated. For example, my handle event. So where was it? Handle event. It's eliminated because it's not used. So sorry for that. Let's say trace handle event called plus methods with a new string 1 and a string 2. And just testing that if it works. So every time I'm now pressing my button there, it says handle event is called with string 2, string 1, etc. So that's working. So generating now again the sources, having a look now at the generated handle event. It's a so-called method. Says again, it's application method, which then just concatenates the string with the constant string and the new arguments that I'm getting by this function. And you see it's now at the more or less at the end of the application at line 174 it is defined. So going back now to embedded wizard, when I now say, okay, this method itself is now restacked to the topmost position, so 184, and generating now again this profile, will then say, okay, this method was already at the end, and this is then taken into account when it is regenerated. And this is something which is important to know when you have different kind of elements. So for example, if you have inline members where you include external header files, then this is also important where this current Z ordering is there, for example. Something to keep in mind that the Z ordering is also important and has an impact when sources are generated. Last thing I'd like to express is something which is also essential inside Embedded Wizard is profiling and analyzing. Something that new with the latest version in 9.30 is the possibility to show the RAM usage. With this screen, you already see how Embedded Wizard initiates different kind of objects and what current RAM usage is. In that case, this very simple application would then take 35 kilobyte of RAM and gives you a proper idea. And with that, you have the possibility to really nail down where are my peaks in my application. Do I have something that could be optimized? And this gives you already during development time the proper possibility to nail down your footprint. And this one belongs to the RAM usage, as well as when having here this build report, but double clicking on that opens the code generation report for the flashes, and that would say, okay, estimated total memory flash size will be in that case 109 kilobyte of Flash, and this gives you also a very nice way of doing things instantly inside the Embedded Visual Studio during development time. However, when it comes also to graphics and to render things inside a UI application is, of course, the number of pixels that have to be processed. The more pixels to be processed, the more impact it will have on the GPU, and the more impact it will have on the CPU. And this is now something which should also be taken into account when it comes to the UI creation. And therefore, we have added the possibility to track the screen updates. By enabling that and starting again now, the prototyper gives you this very big green rectangle, which then disappears. I hope that you can see it, but let's do some very small tests so you see different things. So we have the rectangle, we have there a new move point effect, not move point, sorry, it's a move and resize rect effect, which should be enabled, and this should work on my new added rectangle effects on the bounds. It should be symmetric. That means from one side to the other. And in fact, I'd like to just now copy and paste my initial value there back to this value for my bounds. So just using that and going back now for different bounds. So what I've now just added, defined is how this effect should now work on that rectangle, and it should now bounce from one side to the other and vice versa. And without the track screen updates, then you would see how this white rectangle gets now swiped from the left side to the other side. However, what I just want to mention is for profiling and to see benefits by track screen updates, then you would see what are the current dirty areas of the screen. And with that, you have the possibility to identify even things that are updated but are not essentially updated. Just think about a black text on a black rectangular that you might not see during development time, but with that you have the possibility to identify even those which are, or to identify those elements that are updated, and to shrink them down as best as possible in order to get a better performance on that. So we have the track screen updates. Now, some shortcuts, and then we are finished for today. For the shortcuts, I'd like to mention only a couple of them. So what I'm using most is, of course, starting the prototyper. So that means you see it as well with the mouse overlay. Control F5 on my keyboard just opens now the main application, whereas going to my own, not that one, my screen implementation, by pressing simply F5 on my keyboard opens only the current implementation. Something which is essential when you're new to Embedded Wizard is the so-called context-sensitive help, being there anywhere in the browser and hitting F1 on the keyboard opens now the context-sensitive help of the Embedded Wizard knowledge base, which gives you more information where you actually are, what you are currently focused inside Embedded Wizard. Something which is also very nice to do is to find something inside your application, and therefore there's the global search. Global search is achieved by pressing now Control, Shift, and the F key on your keyboard. This opens that dialog, and then you can say, okay, please find my string handle event that I have set somewhere in my project. I can't remember where it is, but where is it? And then you can say, okay, please ignore the Mosaic framework because that's not essential, and please also ignore any description attributes. And then by pressing OK, then it says, okay, there's now the handle event, which is an inherit method, and there's the trace statement for that method there. And by double clicking now on this element opens now the dedicated found place where handle event is mentioned. So just going back to my screen, anywhere now in the project, pressing Control Shift and the F key on my keyboard, typing in the search pattern, pressing OK, double clicking on that opens the proper implementation. However, what you now see is that the trace statement is open, but this now belongs not to the my screen application. This now belongs to this handle event application. And by clicking here, navigate to the origin, or by clicking, pressing Control Shift O on the keyboard, opens now the class where this current search element or search element is located. And this gives you the possibility to navigate through different systems. So this is for the shortcuts. So just going now back to my slides. Now I talked a lot, and I think there are quite a couple of questions opened. So now it's your turn, and would be pleased if you have selected some questions, Christine, in the meantime, and that we should now cover on. So please go ahead with the questions that we received so far, if any.
Thank you, Manuel. This was very handy in terms of getting a lot of insight, tips, and tricks. I'm sure our attendees really like what they just saw, and I see this also in the questions. They're already popping in, you're right. Yes, let's start with a short one first. How do I import my fonts that I want to use?
Okay, so font management.
Yes.
Something that I mentioned before, not before, in the previous webinar is that inside the application, you could then add different kind of resources. So like the bitmap resource, or this can be added by drag and dropping into the unit as well. However, you see also a bitmap resource, and next to the bitmap resource, there's the font resource. So drag and dropping that font resource would then give me the possibility to define which font to be used. In that way, or what is now working is that Embedded Wizard analyze all the system fonts that are installed inside your Windows system. For example, I have also the Roboto font installed, or I have, I think, no, not Helvetica, but Frutiger, another font also not there. Some Gothic font, etc. These are the system fonts. However, what is also possible inside Embedded Wizard, but unfortunately I have not prepared that, is when you have your dedicated UI project and you would store the TrueType font inside that directory where the Embedded Wizard project is located, then during startup, Embedded Wizard detects that and install that font as well. So it's not essential to install a font for your UI project into your Windows system. Simply store it within the path inside the folder, the directory of your Embedded Wizard project, and then you can simply use it with a font resource like I just said here, but then it's also listed there, but you do not then rely on the installed font, so you can maintain that inside your structure of your GUI project, and this is very, very easy then to have.
It's as easy as that. Okay, so let's come to the next one. Sometimes it happens that the composer does not show the visible objects and the canvas area at all. That seems to be a question of somebody using already Embedded Wizard. What is going wrong? So I can repeat, sometimes it happens that the composer does not show the visible objects and the canvas area at all. What's going wrong?
Okay, I think it was the same that I already had before when I changed from a rectangle to the line, and then everything disappeared. So just doing that again, I have here the rectangle and change that attribute rectangle to line, hitting now reload, and then you see it disappears. Then the entire canvas disappears, the entire border disappears, all the elements that are there. And so the easiest way is going to the log window and see about what's the problem. If you have multiple errors, now I have only one, just have a look at the very first one. Usually all subsequent reported errors are related to each other. So by solving the first error would give you the possibility to fix subsequent errors as well. In that case, it clearly says invalid property name bounds in the initialization of the object rectangle, the object class, etc., etc. We had that before, yeah. So there's the bounds by simply now pressing Ctrl R, removing that, reloading the class in that way. So there's another error because you cannot pass it into the bounds. So now we have a rect effect, I need to change that, etc. So in that way, you could then identify, and as soon as you have fixed that, so in that way, now simply reworking and rolling back to fuse rectangle, going back again, which then resolves that. And as soon as there's no error anymore, Embedded Wizard can then display and render the currently made view, and that's it. So it's a very, very easy way and very, very handy one. That's it.
Thank you. The next question is also coming from an active Embedded Wizard developer that reads like this, so a little bit longer one. Depending on my application, the prototyper does not react anymore on key or touch inputs. How do I avoid such a hang-up situation in the prototyper?
Okay, got it. So that means, for example, let's have something here. We have the method, which is invoked by the handle event method, and let's assume you have done something very not so nice, which is while true, do nothing, something like that. So you have an endless loop inside the application. So what's happening by pressing now again the method there and hitting now enter? Okay, Bennett is very smart and says unreachable code detected and eliminated. The expression is always true of the while condition. So usually what you would have if you have this endless loop situation, for example, when you have some nested expressions. So for example, let's try that one. We are calling ourselves some recursive recursive call, in that way a new argument one, something like that. So calling that every time, pressing again. Okay, it's just Embedded was very smart. So the possibility to stop the current execution of the prototyper is very easy. Just hit pause button on the keyboard, and by doing that, then it would get stopped immediately, and then you have the possibility which is now halted. You can close that so it's not lost, and then you can see, okay, what's happening there in the system, and find your bug where it's currently executed. So with the pause key on the keyboard, you have the possibility to really interrupt the current execution of the prototyper.
Okay, there's of course some more questions coming in, but I'm afraid we have to stop here at this point because I think we could spend another couple of hours to answer them. I would say we're coming back to these individually via email. So yes, Manuel, I think there's some more you want to give our attendees in terms of documentation. Is that right?
Yeah, absolutely. So first of all, as always, please have a look at our knowledge base, especially as also a section which is dedicated to the Embedded Wizard Studio. And if this was not too fast for today, and there are more and lots of more topics to be discovered, so please have a look there. So go to Embedded Wizard Studio. For example, here the prototyper window is there, what to do, what the shortcuts are following this approach, and you'll see if you're handling with key events, you could also then make them visible during runtime. And there's also when the application hangs, what to do. Yeah, so that's all mentioned there. So please have a look at that. Nevertheless, just one further thing to add, because these were a couple of questions that we received the last time going to our website, and the question was, where do I find the recording of the masterclass? And we made this going to the website. That's register for free, which is the masterclass Mondays, and then we had a dedicated landing page. In this one, it's not updated one. We have now this for the old one, and there you see different other aspects, and these are updated right now to give you the possibility to look at them later on if it was too fast right now, and gives you possibility to register yourselves for the next episode. And this is the entry point for upcoming webinar episodes in this series here. So I think that's for now. Further information. So this is the landing page, Masterclass Mondays. We have the knowledge base, and I'm finished for today for this session. And thank you very much for your time. And please do not forget to vote for the next topic to be covered in the next webinar next week. So thank you very much for your time. And from my side, I'd like to say goodbye, stay healthy, and take care about yourself, and hope to see you soon. Bye-bye.
Yes, thank you also from my side. Manuel just pointed it out. We would appreciate if you could spare 1 more minute after the webinar closes in order to fill out the question, what topic should be covered next week. So have a nice evening, afternoon, morning, whatever time zone you are now watching, and then hope to see you next week. Bye.